Hello, welcome to the second of our Shotgun Dev Day replay webinars. As we mentioned in the last one, we had a Developers Day at SIGGRAPH in Vancouver that was super awesome, that a lot of people showed up for. We thought that the content was really useful, so we wanted to make sure that we had it available as a recording for anyone who wasn't able to make it. And with having a webinar today, for those of you who are here in person, you can also ask questions. Today is the second of three. It's going to be on Toolkit Administration. We're going to start with Phil Scadding, and then myself, and then Josh Tomlinson. So without further ado, I will hand it over to Phil. If you guys have any questions, feel free to put them in the little Q&A box, and we'll try and get those answered at the end of each of our presentations. All right, Phil, how are you guys?
Okay, great. Cheers, Tannaz. Thank you. Okay, cool. Yeah, so as Tannaz said, we've got three presentations today on sort of Toolkit administration. So I will be starting the talk about what shotgun integrations are and how they can help. Tannaz will then cover tailoring the integrations to your needs through customization. And then lastly, Josh will be talking about even deeper configuration through the use of custom code with our hooks. So, shotgun integrations. This is the first talk. So it's aimed at those who aren't familiar with our integrations or perhaps haven't used them for a while. And we'll mainly focus on what the user will experience when using them. We'll cover what challenges the integrations can help you solve. I'll run a demo of an example workflow using the integrations. And by the end of it, hopefully you'll have an idea of what they are and how they can help you. So to start things off, Shotgun is great for your supervisors and your producers. They're able to track their shots, make sure people are working on things they're assigned, the timings are right, keep track of things that need to be reviewed and stuff like that. But your artists are wanting to work within their DCCs, so things like Maya, Photoshop, Nuke, etc. So there's a little bit of a disconnect. They're spending their time in the DCCs, whereas your supervisors are more happy to be spending their time in Shotgun. So the Shotgun integrations aim to sort of bridge that gap by bringing the Shotgun data within the DCC, so the artist doesn't have to leave their software in order to benefit from Shotgun. And it does this by allowing, bringing up an interface within the DCCs to allow the Shotgun data to be displayed, and then also allowing the Shotgun data to be modified through the use of the integrations within the DCCs. Beyond that, it helps introduce or improve the consistency in your workflows by allowing you to organize your file system and have your file names named in a consistent way. And tools can be written by your TDs, actions or custom tools can be added on top of our integrations to, again, just help make the workflow more consistent for your artists. So when we talk about software integrations, here are some of the integrations that are available. So you've got Maya, Motion Builder, 3ds Max, Flame, Houdini, Photoshop, Unreal, Nuke, and Mari. There are some community written integrations as well. As the integrations are written on top of Toolkit, which is our framework, the developers can write their own integrations using that. So the best place to start when talking about integrations is our basic integrations. And as the name suggests, there's advanced integrations as well, but we'll cover those in a minute. So we've aimed to make Shotgun integrations more accessible and reduce the barrier to entry. Basic integrations are quick and easy to set up, and they contain the fundamentals of what you need to connect your software and artists to the Shotgun data. And by fundamentals, I'm talking about things like the Publish app. So the Publish app is a way your artists can say, hey, I am done with this piece of work. I'm ready to share it or present it for review, for example. And allow other artists to get hold of those files that are published by creating published file entities in your Shotgun site that can then be tracked. And to complement that workflow, we then have the loader, which completes that handover, the workflow, so other artists can then navigate to your asset or your shot and import in the asset, the scene files or renders, whatever it is that may have been published. On top of that, we also have the Shotgun panel app. And the panel app is designed to allow the artist to get the information they need to do the task from within their DCC. So they're not having to jump into Shotgun to look at this information. It's all there, ready for them in Maya or Photoshop or Nuke or whatever it is they're using. And it's just going to allow them to help not break that flow. They're not having to jump around to get that information. So next, what I will do is run a demo of how easy it is to get up and running with the integrations. And then following that, we'll dig into a more detailed example of simple workflow with it. So here we have a video demonstrating this. And first of all, you would create your project as normal. And then if you haven't already, you would go to your Shotgun site and download the Shotgun desktop app. This would need to be done per user. And once it's downloaded, they would then sign in with their usual Shotgun credentials, the same ones that they would sign into the Shotgun site. Once desktop is installed and opened, you can then pick the project you want to work on. That will then initialize those integrations, and you're presented with a bunch of launchers that you can then use to start up the software, for example, Nuke. And then within Nuke, you've got your Shotgun integrations like the panel app, the loader, and the publisher. And it really is that simple. You just need to download desktop, have your project already created, and you're away. And there's no more configuration needed. So that's how we got set up. That's how we get set up. Let's now move on to our more complex demo. So in this demo, I will be playing the role as a supervisor, and I will be assigning an artist a piece of work in Shotgun. We'll then be putting on our artist cap and jumping into Maya, finding our task, producing a shot with some rendered images, and then publishing them. Then we'll be jumping into Nuke, creating a comp using those rendered images, and finally reviewing the footage within Shotgun again. So completing the circle and making sure the data is tracked all along the way. So to start with, as a supervisor, I would go to my shot or a shot and assign the artist to a particular task. And then maybe I would leave a note or something just to help put some emphasis on the task for the artist, or give them any details they might need in addition to what's already on the shot. And that's really all that's required from the supervisor at this point. They've handed out the work, and it's now ready for the artist to go off and begin working. So jumping over to the artist's point of view, what they will be doing is launching up desktop, as we saw, picking the project they want to work on. And at this stage, they're not picking the task they want to work on, they're picking the software they want to start with. So we're going to launch up Maya. It's also possible to launch the integrations through the Shotgun web. If you've got desktop running, you have action menu items available, so we could have launched it from the context of a task, for example. But as we can see, Maya's started up and it looks all normal. There's standard Maya, but on the right-hand side, we have a Shotgun panel appearing. Now, what this is showing us is that we can see we've jumped straight into the My Tasks tab, and we can see all of the tasks that are assigned to this particular artist. There's also a Set Work Area button. Now, this Set Work Area button allows us to tell the integrations what context we want to work in. So by pressing this, I'm saying, hey, I want to work on this lighting shot, this lighting task on this shot, and then all of the integrations can be aware of the context and behave appropriately. And I'll show examples of that as we go through. But now we've set that, you can see that the Shotgun panel has changed what it's showing us. We can now see the activity feed for that task and shot, as well as the notes, versions, the published files, the other tasks on the shot, and any additional details that is also available in the shot. Beyond that, what we want to do now is let our supervisor know that we're actually beginning to begin work on this. So we can see the status is set, ready to start, and we can run this action here to to set it to in progress, and that will update the status on the task in Shotgun and allow our supervisor to keep tabs on what the artist is up to. So now that's done, essentially we've done everything we need to do to get started on the task. So we'll actually begin building up our shot now. Now, in addition to the Shotgun panel app, we also have the Shotgun menu here, and we've got a few more options available to us. So we've got the Shotgun panel, but we also have the Publish app, the loader, and also a sync frame range app, so we could sync the frame range if we had it set on the shot into our Maya scene. But for now, what we're going to do is use the load app. Because we're building up a shot, we're going to want to load in perhaps some assets that have already been published previously by another artist. So on the left-hand side here, we have a list of entities. We've jumped automatically into the shot because it knows our context, so it thinks maybe we want to load something from this shot. But in this particular case, we're going to want to go and browse to a character asset and bring that in. So if we navigate through the structure to have a look at the Trilobot, we can see all of the published files that are available on that entity. And we have this particular Maya file down the bottom here, which I want to bring in to my scene so I can start laying it out. In this case, I'm going to reference it, but I could have imported it. And I would obviously typically load in a bunch of other assets, and my scene's going to require more than just the Trilobot. But for the moment, that's great, and we'll skip ahead to when the scene is built. But as you can see, we now have the reference loaded into the scene. So, skipping ahead a little bit, we now have created our scene. We've got a camera, we've got all our assets inside, the lighting done. We've also produced some renders. We've got some render layers in there. So what's left for us to do is to go ahead and publish this. We've completed the work, and we're ready to make sure that that stuff is tracked, and our supervisor knows that we're finished, essentially. So I've opened up the Publish app, and you can see that it has gone ahead and scanned our scene and found some things that can be published. So we found, first of all, the Maya scene itself. So it's important to keep track of what file created these renders, as well as all of the render layers as well. And on the right-hand side, we then can see the context that we want to publish to. Again, because we set that work area at the beginning, it knows what context we want to jump into. We can then draw a little thumbnail for our publish and fill in a description of why we're publishing it, which is important because if you go and have a look at the publish file entity later, we can see why was there a version 2 or a version 3. So it's useful to have that stuff. We then can run a validation. This will run a simple check over the scene just to make sure that what we're publishing is okay. And then we can go ahead and press publish. And it will go through each one of those entities and create publish file entities in Shotgun, which we will be able to see in a minute. Great, okay, so that completed fine. What we'll do now is jump over to Shotgun and have a look at those. In a minute. So what we have here is the task page on our shot, and I've got a Publish Files tab, which is showing the published files that have been associated with this task. And we can see the Maya file and the various render layers for the EXRs. What we haven't got at this stage is a playable version. We just have EXR sequences, and for a playable version, we need a mod file. And so there is our next task to create a comp of these renders and create something that can be then reviewed within Shotgun. So the Maya artist is finished. We're now ready to jump over and be the Nuke artist. So again, we're going to go into Shotgun Desktop, we're going to launch Nuke, and again, it's pretty much the same workflow as if you were in Maya. We've tried to create a consistent workflow, so we've got the same apps and same behavior across all of the DCCs. There are some individual apps for the particular DCCs, but again, we're going to set the work area to the task. You can see that the panels change, and now we're ready to load in our renders. So if we use the Loader app, it should then show us the renders for our particular shot. And it's jumped straight to the right place, and we can see the renders. So what we can do is then import these into our scene and have read nodes for each one of these renders. You don't have to press the action button and then choose that. If you can double click it and it will choose the default action. So that's loaded in all of these read nodes. What's left for us to do now is to pump those together so that we can see all of the elements laid over the top of each other. And of course, we're not going to do that right now. We're going to skip ahead to when it's done. And we can see our spaceship flying towards the planet in space, which is great. So now what we want to do, now we've created that comp, is get it uploaded to Shotgun. And to do that, we can come over to the left-hand side here and use the Shotgun Quick Review node. Now this is similar to the standard nuke write node in that you would put it at the end of your graph and you would then be able to render out that footage and upload it to Shotgun. There's not actually a lot going on in the review panel here. All we need to do is press this upload button and it presents us with this interface. So the output of this is going to be a version. So we can give the version a name. We can set the context. Again, it's automatically set for us because we set the area. We can give a description of why we're going to create it, fill in the frame range of the footage that we want to upload, and we can choose to add it to a playlist if we wanted to. In this case, I'm not going to, but we could do if we wanted to. So when we press upload, what it's going to do is it's going to go through and render all of that footage into a MOV file. And as fascinating as that is, we haven't got time to sit and watch it all. So again, we'll skip forward to the point where it's created the MOV file. Now it's going to take that MOV file, upload it to Shotgun, and then give us a few options on how to proceed next. So at this point, we could just close out the interface, or we could view it in the panel. But what I'm going to do is click the Show in Shotgun button, and we'll take a look at it in the web browser. And there it is, the playable footage for that shot, already in Shotgun. And so now your supervisor can see it, make sure that everything's okay, and review it, or perhaps send it off to the client review site so that your clients can, of course, review the footage. And that concludes the demo. We've gone from Shotgun into our DCCs. The artist was able to get all the information they needed to do the work, and then publish that information and share it back into Shotgun so that it's all tracked. So in summary, it was simple and easy to set up. It's good for small studios who maybe don't have the dev resources to maintain a complex pipeline. It allows for auto updates, so you don't need to worry about your artist's desktop version being out of date or out of sync with somebody else's. They're all going to be kept up to date. And it's allowing you to complete that publish and loading workflow in your studio. So now is a good time to move on to the advanced integrations. The basic integrations are a great place to start, and for some that may do everything they need it to do. But others, they may find that they need something a little bit more flexible or something maybe a bit more powerful. And so the advanced integrations has all of the stuff that the basic integrations have, but some extra stuff on top. For example, it has the file and folder organization, which the basic integrations doesn't. The basic integrations will publish your files in place where the user chose to save them, whereas the advanced integrations will manage where those files should be being stored and how they should be named. It also contains more apps, such as the save and open apps, or example, a nuke write node. There's also a sort of specific apps that are available for particular DCCs using the advanced integrations. And where it really becomes powerful is the configurability or the extendability of it. Now, this is ideal for studios that have, as I said, those dev resources to be able to build upon top of what we provide. We don't know exactly what your individual requirements are going to be. We provide a useful starting point, an out-of-the-box solution, even with the advanced integrations. But you can then build on top, and you can either add custom apps or integrations, or even just tweak the behavior of our provided ones so that they're doing the things that you need them to do. So what I'm going to do now is just show a little demo again of how to get set up with the advanced integrations. Just like as with the basic, you would download desktop and start it up, sign in. You'd then pick the project and it would load the basic integrations. And what we're going to do is we're going to run an advanced wizard setup for the configurations. This doesn't need to be run per user. So this would typically be run by the person who's going to be maintaining it. We can jump down to here and choose the advanced setup wizard. So we have a few options here. We can pick the Shotgun default, which is our default configuration. You could choose to pick the configuration from another project. So if you've set one up already and it's working well, you could use that as a starting point. Or maybe you've got one in Git or another one on disk. But in this situation, we're going to use the Shotgun default. And then we're going to choose to use the latest rather than our legacy one. The next thing you need to pick is the storage route. So this is where your project data is going to live. So if I'm saving a Maya file, where is the route where my project folder is going to be stored, where my data will be saved? And you can see that we can define a route for the various OSs. We can have multiple routes if we wish. But for the moment, we're just going to keep it simple and go with a primary one. And then pick a project folder name that will be then added onto that route and form the basis for our project data folder. Finally, we then need to pick a configuration location. And this is where all of the guts of what makes it a toolkit configuration is going to live. So you've got all your configurable files and your apps and the core all going to be stored there. And this needs to be stored somewhere on the server again, like project data, where it's accessible to all of your users. They don't need to know it's there, but they do need to be able to access it through the code. So once we click continue, it's then going to go ahead and download all the apps and create that configuration on disk. And it will be up and ready to use for all of your users running on that project now. So what I'll now do is jump in and give a little demo of some of the advanced features that are available, or some of the key differences that set it apart from the basic integrations. Looking at desktop, it looks much the same as the basic integrations. We've still got the same launchers available to us, like the standalone publisher and all of the other DCCs. Where it really changes is once you get into the applications themselves and start using the apps. So we'll launch Nuke and have a look at some of the differences. But again, this applies to the other DCCs as well. So like with the basic integrations, we still have the Shotgun panel apps start showing up, but we don't have the set work area button. And the reason for this is that as we're now managing where your files should be going, it makes more sense to pick a file as a starting point rather than choosing the context and then going to find the file. So instead, we have the file open app. Now the file open app allows you to choose a task in which to start working on. So you've got My Tasks, you've got Assets, Shots, and you can configure it to have more tabs available if you want, if you're working with different entity types. Currently, we haven't created any files, but you could, for example, drill down into a shot and work on a task that maybe didn't belong to you, or just check what's going on there. And you can see the different working files and publishers. But as we don't have any files, what we're going to do is pick our task, and we're going to go down and press the New File button. Now what this is actually going to do is not create a new file on disk just yet, but it will set the context again, like the set work area, and it's going to reset our scene. So you can see that the Shotgun panel app is again changed to reflect the status, the context that we've entered into, and we have a bunch more apps, which I'll go through in a minute. So the first thing we'll do is just create a comp, and no comp could be complete without a color wheel. And so we have now finished our comp, and we're very proud of it, and we want to make sure it's saved. So we've got, as I said, a bunch more options available to us now. This menu is context driven, so what you see in there is going to depend on what context you are in. And so we've got things like the file save app, scene breakdown, the frame range sync, file open. But we're going to use the file save. Now there's a bunch of options here. We could actually choose at this point to hit the arrow and pick a different context to save this file to, but for the moment we're in the right context and we want to save our file here. So we can enter in a name for the file, or if you prefer, you could configure this so that the artist doesn't have the option to fill in a name. Instead it could be maybe the name for the file is driven from the shot or the task name, or maybe a combination of both. It's up to you to configure that. Secondly, then you can see the version. So it's going to automatically pick the next version for you, and since we haven't saved a file before, it's going to be version 1. And finally, we can see where it's going to save it. Now, it's decided this for you. The artist doesn't need to choose where on disk it's going to be saved. It's found that automatically. And if we go back to the Save app, we can see that the next file is going to be version 2. So again, it's just helping that consistency in your work file. You know that the artists aren't going to be saving it in random places. It's going to be saved in the place appropriate to the context. And if we open up the File Open app again, we can see that we could now open up that file. If we were to leave and need to come back, it's there, and we can use that to open up and carry on from where we left off. So I will show you what the File app, Save app does in a minute, where it's put that file, but to start with, next we're going to have a look at the new Write node. So the Shotgun menu on the left here that we use for the quick review node now has a bunch more options, and these are presets of our Shotgun Write node, which you can configure. You can have your own presets for different output types, but I'm just going to pick this one, and it's basically the same as the normal Write node, except it's now going to take care of, again, the paths of where things should go and how they should be named. So we have the ability to give the file an output name, and that forms part of the file name. But again, that's all been decided by the templates, and that's fully configurable. So all that's left for us to do is to create a render, and then we can show how to publish that data back into Shotgun. Previously, with the basic integrations, we used the quick review node, and that's still a perfectly valid option here. But what we might want to do is use the publisher so that we get a published file entity as well. So let's just skip into that. So again, jumping into the Publish app, much like with Maya, it's gone and gathered all of the available things in the scene that can be published. You can fill in a thumbnail. So it's gathered the Nuke script, and it's also found our Shotgun Write node with some footage, and it's offering to create a published file entity as well as uploading it for review. So we can also create that version in Shotgun as well. So if we just continue with that, what it will do now is jump through the render that footage that's available in our scene and create a uploaded version. So I'm just going to skip ahead a little bit here because we're finished publishing, that's all successful. What we can now do is have a look at the File Open app again, and we can see our published file is now available to open. So again, we've got that distinction between working files and publishers, which I'll draw home in a minute, but the published file is version 1, and we've automatically versioned up the working file to be version 2, because we don't want to continue working on version 1. We want to make sure that next time somebody comes to work on it, they're going to be working on version 2 of the file. So what's going on disk? What's actually happening here? Now, what we can see here is we've just jumped to the folder structure for the context using that app, and we can see that we have our files here. Now, all of this folder structure from the project root onwards was automatically created for us from Toolkit. When we chose the context, it's gone ahead and created all of that folder structure for us. We've got so we can see actually, sorry, that we've got a dynamic folder structure based on our context. We've got the shot and the sequence and the task name forming the folder structure. And then within there, we've got a publish and a work folder. So when you're using the File Save app, what it's doing is it's creating files in that work folder. It's not registering them in Shotgun. We don't want to track them. We don't want to necessarily share them with other users. These are the artist's work in progress files. And the same goes for the renders as well. When we've been rendering them, they've been going into the work folder. However, when we then publish, that data is then copied over into the publish folder and given the appropriate version so that it can be tracked and then not touched. So the published files are designed to be set in stone, a slice in time of the work that was done. Whereas the working files are designed to potentially be throwaway. Maybe at the end of your project, for example, you might say, okay, we've got everything we need in our published folder, we can get rid of all that working stuff. So it's a good way of just separating out and making sure that you can rely on what's been published and it shouldn't be modified, basically. And that brings us to the end of our advanced integration demo. There are more features with the advanced integrations, but this is just highlighting some of the key differences with that from the basic integrations. I'm not going to go into the advanced integration, the customization now. That will be for Tannaz to cover. So before we go on to the next talk, are there any questions, or are we doing questions now?
We have one quick question. Chris Spears was asking about getting the, how easy is it to get the Shotgun Nuke write nodes working on a render farm? Josh sent him the doc, but if you want to go over the couple options that we have there real quick.
Sure, yeah. So our recommended workflow is we have a method which allows you to convert it to a standard Nuke write node. So the method would be that typically you'd have that Shotgun write node to the point where you're going to submit, and then you would convert them to standard write nodes so that they work on the farm. There is another option, which I'll cover in a second, but we are also looking at maybe ways we can improve that with. At the moment, it's designed so that you would write maybe an integration into your render farm submission so that you could call that convert, and that would be the best way of doing it. We're also looking at providing a visual option so the users can click that and convert within the interface itself. But the other option we have is to bootstrap onto the farm, so you could start up Toolkit on the farm. We tend to not suggest this. I mean, there's a couple of flaws with that. For example, every time you're bootstrapping, you're going to be slowing down your renders a bit more, and it's also going to be reaching out to your Shotgun site. So if you've got a lot of render nodes connecting to Shotgun, then it could, have an adverse effect on your Shotgun performance if you're pinging it loads and loads of times with quick renders. So yeah, my recommendation would be to make use of the convert methods. Hopefully that answers
that was the only question we had.
Awesome.
So unless there's anything else, I will take the screen from you.
Brilliant. Yes, I'll hand it over. Thanks, Tannaz.
Thank you.
If I can hand it over.
Okay, so I'm going to pick up where Phil left off. I am controlling and reading this presentation from my phone, so bear with me. Okay, let's begin. On order of an intro of myself, in case you guys don't know me, my name is Tannaz Sassooni. I have been at Shotgun for about 2.5 years. Before that, I was a pipeline TD way many years ago at Rhythm and Hughes for a few years, and then was at DreamWorks Animation as a pipeline TD in various departments there, mostly animation and character effects for almost 9 years, and now here we are. We didn't mention it early on, but we do have a GitHub repo with a bunch of resources from all of these courses. This QR code will get you there if you want to grab a screenshot. We also have this awesome graphic that Mason Jarrett, one of our extremely talented street team members, has designed for us, and we super love it. So we just wanted to call it out. Now let's continue. So, Phil talked us through the basic integrations that are like you install and go. There's nothing to configure. You get your publisher, your loader, and your Shotgun panel inside of your DCC, super easy. And he talked us through like what your advanced configs buy you from there. The idea being like you want Toolkit to manage your folder structure, or you want to add an app beyond those basic three, such as our, Shotgun write node, for example, Nuke, or you want to add a non-default integration, such as the Unreal Engine integration that they just announced. At that point, you're ready to take over your configuration and begin customizing it. So when you do that, you're going to get a pipeline configuration on disk. We're going to talk about what's in there, and we're going to look into it. Before we look at the files and folders, let's talk about a few quick Toolkit concepts and the notation that we use for each of them in our configs so that you know what you're looking at once we dive in. So the first one is an app. It's basically a variety of public-facing user interfaces that do something pipeline-y. It can be anything from a panel in Maya, a node inside of a Nuke script, a dialog, a standalone app outside of a DCC, like our standalone publisher, or a deeper integration into a native dialog. So what you're seeing here is our Nuke Studio exporter that takes Nuke Studio's own exporter and adds to it. As far as notation, you can see here with TK multi-work files and TK Nuke write node, 3 words delimited by dashes. The first one is TK. The last one is something descriptive. The second one can be one of 2 types of things. For something like the Nuke write node that is specific to a DCC, that second word will be the DCC that it is specific to, or the engine that it's specific to, in this case, Nuke. As Phil talked about, we do like the more general apps to feel the same across DCCs. So for those, we have the same one. So like for our Workfiles 2 app, which is what the file open and file save are, those are the same within Houdini, Nuke, Maya, etc. And so we call those multi-apps, and that is, that's why, that in those cases you have multi as the second word. So that's that. Which leads us to engines. The engine is the bridge between the apps and the DCC. Our engines hold the DCC specific logic so that we can have multi-apps that behave the same from one to the other. There are some special, so the kinds of engines we have are they typically correspond with the DCCs that we support. There are some special engines as well. TK Shell is one of them. That is the one that manages the software that you can launch from the command line. TK Shotgun manages the software that you can launch from the right-click menus on entities within the Shotgun web app. And TK Desktop manages the software and the apps that you can launch from Shotgun Desktop itself. As far as notation, it's pretty simple. 2 words delimited by dash. TK is the first word. The second word is the engine or the special thing. Or rather, the DCC or the special thing, like Shotgun, Shell, or Desktop. A few more of these engines. All right, let's move on. Environments. The context in which Toolkit is running is what we call the environment, and it's based on what you're working on. The idea here is that when you're configuring Toolkit, when you're configuring your pipeline, you might want to have different workflows for different artists working in different contexts, in different environments, right? So the way that we have it set up is that we divide by shot step and asset step. So the idea is that you might have your artists that are working on assets, such as like modelers, riggers, surfacers, these kind of artists using a set of software, whereas your animators, effects artists, lighters, etc., that are working in shots have a different set of software. You can divide this further. As most things are in Toolkit, it's quite customizable. So, for example, if you have a studio where it goes even further, you are divided by department. So, of course, like your animators might be running Maya, your effects artists might be running Houdini. You can make those available and clean up the stuff that they aren't necessarily using. You can take it even further where you have effects artists using Houdini, but you also have cloth and hair artists using Houdini, but for various reasons they might be using different versions. You can set this up there. And additionally, Toolkit apps and engines themselves can be configured differently, make specific tasks available, make shots versus assets available, etc. So that's the environment. And finally, core. Toolkit's core API, its public API, as well as the underlying code, like the public API that you guys can also use to write your own Toolkit code, as well as the underlying code that drives Toolkit. By default, every pipeline configuration for each individual project has its own self-contained copy of TK Core. You can change that. You can share core across your studio, but this is where it begins by default. And again, that gives you that control where different projects can be on different versions. The notation is simple. There's only one, and it's called TK Core. So now that we've gotten some key concepts out of the way, let's talk about folder structure. Basically, we're picking up where Phil left off. He ran us through the wizard that creates an advanced configuration for you. Once you've completed that process, you have a bunch of folders and files on disk. When you go into that root this is what you see. 3 directories and a couple files. Going through them, the cache directory is for internal use. We're not going to worry about it today. Config, we'll skip for a moment. The install directory holds Toolkit core or a pointer to it if you're sharing core across, as well as all the apps and engines that your configuration is using. You have tools to manage it, so typically you won't be modifying it directly. The tank command is a collection of command line tools for managing your configuration, launching software, doing a bunch of cool toolkit things. And tank.bat is just tank as a batch file for Windows. So that leaves us with the config directory. And that's where we're going to dive in. Config is where you'll customize your toolkit pipeline through a set of YAML files and simple but extensible pipeline scripts. So let's take a look inside. I've cleaned this up a bit. There might be some other random things in these directories, but these are the ones we'll want to worry about today. What do we see when we step into config? We see some familiar words, right? We know what core is now. We know what environments are. So as you might guess, the environment directory contains your per environment configuration settings. Your core directory contains configurations for core as well as other non-environment specific stuff. Let's take a look at core first. You see a bunch of files and folders in here. We're going to focus on 2 things, the schema and the templates. We've mentioned that Toolkit can manage your folder structure and your file naming. Schema and templates in the pipeline config are where that actually happens. So if we go into that schema directory, you'll basically see a templated mini version of what you want your production file system to look like. The folder names are generic, sequence, shot, step, etc. But as much as you want them to be, they're dynamic and they'll be replaced by the names of actual entities in your production. Some of them are static. For example, the assets directory will actually be a directory on your in your production file system called assets. But the dynamic ones each have a YAML file corresponding to them that describes the way in which we want them to be dynamic. So you have an asset directory, you have an asset.yaml, you have a step directory, you have a step.yaml, so on and so forth. I'll also mention here, we are looking right now at the schema inside of our default config. Customizes easily for your production. You just add or rename folders, change the rules in the YAML files, and you're off to the races. So let's keep going. Let's take a look at one of these YAML files. We're going to look at asset.yaml. Okay, so looking at this quickly, what we see is the first setting is the type. We see that it's a folder of types Shotgun entity. So essentially, we're going to get the naming of this folder from an entity in Shotgun. It might make a little more sense to look at these switch. The entity type setting first is, well, okay, which entity are we going to look at? We're going to look at the asset entity. And name is the specific field that we're going to get from that entity, and in this case, it's code. So that's pretty much it in this case. It's pretty intuitive, right? You go to you have an asset directory, you go to the asset, you get its name, you name the folder after it. Further down, we have some filters. These are also pretty basic. It's just, am I working on the right project? Is the asset of the asset type that I expect to be on? If so, then let's go ahead and make folders. So that is, a YAML file inside of your schema describing how to name folders in your actual file system. So let's drive the point home a little bit. Say you have your schema built out in such a way that you'd have a path that looks like this. 4 pipeline steps on assets. Project, assets, asset type, assets, step. So you have a rigging step on your guy Sven on the Hyperspace Madness project. When you create folders, they'll look something like this. Hyperspace Madness is the project. Assets is a static field in this case. Asset type is character. He's a character, of course. The asset is Sven, that's his name, and the step is rigging. So that's schemas. Let's talk about templates, right? We've seen how the schema controls the folder creation and naming. What about naming of files? And that's where templates comes in. Similar to what the schema is for folders, templates.yaml file holds templated keys that are used to build paths and file names for use in your toolkit workflows. So let's take a look at that file. At the top of templates.yaml is a keys section. You start by defining a series of template keys. Again, dynamic fields you'll use further down in path and file templates. Let's look at what we have here. These top four are pretty basic. They correspond, again, to entities in Shotgun. Because, I won't go too deeply into this, but because you have built out a mapping of entities to naming in your path through your schema, these ones will get their names from there. So if you have sequence in your path, you get sequence here kind of for free. The name template key is a special one that corresponds to user input at file save time. So you saw in the file save dialog that Phil showed us that the user can enter a file name, or enter a field that can be a file name or part of a file name. That's what this name key corresponds to. In this case, we have the filter by setting, so it will only allow alphanumeric input. Another couple things you can see here, this is another string type template key, but it has choices, right? You can choose between my ASCII and my binary, and you also see our default setting, which is often used in these cases to set a default, obviously. So that's our keys. Further down in that same file, here's a snippet from the paths section. Specifically what we're looking at here, these top three are sort of common bits of paths that will be used over and over again. So rather than include them in every template, we define them here and then refer back to them in our templates: shot root, asset root, sequence root. Further down, we see some actual templates finally. My asset root, for example, uses that asset root sort of sub-chunk that we defined further up, a few other folders, and then you can see that name field that we had defined up above, a version field, as well as that my extension choice field that we had defined up above. I'll mention, it's pretty obvious, but they're delimited by curly braces inside of the templates. We also have my asset publish. It's essentially the same except for that it's writing it to a published directory instead of a work directory. The root name, I won't go too deeply, but storage roots are just like you can define places that files can be written and read from. That's what these root names refer to. So what else can I tell you? One thing I can mention here is, we keep saying that we're talking about files with templates. So why are we talking so much about folders? Well, it's important to understand, right, that these files are going to be written in the folders that your schema has created. So it's important that the paths that you define here are in step and match perfectly with what you've defined in your schema. The schema writes the folders. The templates are used to read and write files from those folders. I'll also mention quickly that what I've described here as far as templates and schema is a very small subset of the options that you have for customizing your file system management. We have a document called the File System Configuration Reference. It goes through basically every option that you have. So it's a really useful one when you're figuring out the directory structure and the file naming for your pipeline. It's referred back in that GitHub repo that I mentioned at the beginning, so you can get to it from there, or just search for File System Configuration Reference in our documentation. All right, so that's templates and schema. You've defined some templates, but what we've done so far, we're not actually doing anything with those templates yet, right? We've defined them in templates.yaml, but they're not really in play in our toolkit workflows yet. So let's look at how they do come into play. And then that comes into play in the environment configuration. So going back to our config directory, we talked a bit about core. Let's talk about env. When you go into env, you see an includes directory, a README that's actually a very useful resource, and also a bunch of YAML files. These should also look familiar because they correspond to those environments that we talked about early on. So this is where this is where those environment-specific configurations are defined. Let's look at one of them. Since we're interested in seeing how the Maya asset work template is put into use, let's look at the asset step environment config file. We open that file. There's nothing in here about Maya asset work or any templates. What we see instead are two blocks. The includes block at the top is a way for us to define includes. They are a way that we can define something in a single file, but then reference that information in other files. We use includes extensively in our default configuration so that we can reuse settings, keep files short, and not have to make modifications in multiple places. The second block is the engine block. You'll see that each of these settings has a value that starts with an @ symbol. That is a signal to us that this is a block of YAML that is coming from one of the files that's been included. So in our case, we know we're looking for information about TKMaya. So we're going to dig into that settings tkmaya.yaml file, and specifically we'll look for the block called settings.tkmaya.assetStep. So quickly, we'll see what we're looking at here. Going back into our environment directory, we saw that there was an includes directory in there. That settings directory is in there. There's a file in there for each app and each engine. We're going to look at TKMaya. So when we do, and this is kind of an abridged version, but the general structure is similar. You have the includes up at the top. There's nothing, again, about any templates. But after the includes in this engine configuration settings file, you see a bunch of blocks for different environments. So here we have settings.tkmaya.assetStep. That's the one that we were looking for because we know that that's what's included in the file that we were looking at, assetstep.yaml. And we know we're looking for a work file, my asset work. We want to follow that. So we'll follow the tk multi-work files include and find the block that is mentioned here, settings.tk multi-work files to.maya.assetstep. Let's go in. So we open that file, and here's its contents. Finally, we see some templates. And we do see my asset work is in play here. So what's going on here is we're looking at the app configuration settings for the TK multi-work files 2 app in the Maya engine in the asset step environment. And we can see that it takes a template work configuration setting, which is right now set to the value of Maya asset work. So what's going on here is that in the work that work files does, in its logic, when it needs the template work setting, it's going to look to the Maya asset work template that we had defined in templates.yaml. So that's where your templates come into play in your environment configuration settings. So that's pretty basic. We figured out how to set up a template, but it's important to note that that concept carries out to all of the settings for all our templates. We can make changes here to templates, but there must be more, right, than 4 configuration settings for work files too. That seems kind of odd after we've been talking about how configurable this is, but there's only these 4 templates to configure. That is odd, and in fact is not the case. What we're looking at here is a sparse configuration. The idea is that we don't list all of the settings that are available for work files too, only the ones that we have modified from the default. So the next logical question might be, so, okay, how do I know what's even available for work file 2? How do I know what I can customize in my configurations? Well, that's where a file called the manifest comes in. The idea here is every single one of our bundles, apps, engines, frameworks, I believe core itself, has a file called info.yaml in its root, and it contains every single configuration setting that is available for that bundle. As well as a description of each and what kind of value it takes. So you can see that just for this one app, there are many, many configuration settings. And that's basically the power of Toolkit Pipeline Configuration. With simple tweaks in these YAML files, you can quickly make all sorts of customizations to your pipeline. And that's pretty much pipeline config. So once the slide advances, let's look at one last thing quickly. We looked at the core directory, we looked at the environment directory, and that leaves us with hooks. The idea with hooks is that, as we saw, it's easy to change a value for a configuration setting by modifying your YAML files, but sometimes you want a deeper customization. You want to inject custom code, not just these values into your workflow. And that's where hooks come in. In broad strokes, when you customize a hook, it goes into that hooks directory inside of your pipeline configuration. And it's taking over a hook is a little bit more work than modifying a config, but it gives your pipeline infinite extensibility. So in the next half hour, Josh Tomlinson is going to demo taking over a hook and customizing it. But before I hand it over to him, I wonder if you guys have any questions. And I can't see the questions right now because I have the slideshow at full screen. So if there are any questions, someone can let me know.
There are not.
Okay, so I will stop sharing my screen and hand it over to Josh.
Okay, share my screen. All right. So just kind of going to build off what Tannaz already said. The goal of this section of the webinar is to give you an overview of hook and hook management. So we'll kind of go off what Tannaz said and just kind of talk a little bit more about how you can customize Toolkit a little bit deeper than the configuration once you're ready for that part. Hold on, focus. Okay. Okay. So a little bit about me. Like Tannaz, I worked at Rhythm and Hughes for a long time, and then took a little brief detour at in academia, and then ended up at Autodesk with Shotgun. I've been here for 3 years. So what are we going to learn in this session? We're going to talk about basically a broad overview of hooks, identifying and customizing them through the configuration. We'll look at a couple of publish and load examples just to give you sort of a production view of what that means to customize some of the default behaviors in our apps. And then we'll talk about overriding versus subclassing, and then a little bit about best practices. That's just the broad scope of what this section is about. Once again, the GitHub repo for all the resources from Dev Day and all these talks, all the snippets of code that I'm going to show are in here, and you can use those to try them out and play around with them. So we'll start with a quick overview and refresher of what hooks are in a practical sense and how they're specified in the configuration. So what are hooks? Hooks are pieces of execution logic that are available for customization in Toolkit apps. They're typically exposed in portions of an app that require studio-specific behaviors. So if we take the publisher, for example, which you've seen earlier today, the logic that defines what items are going to be published is exposed via a hook. And then similarly, the logic that defines how those items are going to be published is also exposed via hooks. So in other words, hooks allow you to build your studio's business logic into existing apps without having to roll your own solution. How do I know what hooks are available for a given app? Like Tannaz mentioned, every Toolkit app includes a top-level info.yaml file that defines all the configuration settings for that app. All available hooks for the app are defined within this file as settings of type hook that can be overridden in a client configuration. So you should check your configuration to see what hooks are used in the various contexts. These are often engine-specific. So for example, Maya-specific publish hooks, Nuke-specific publish hooks example. Also, like Tannaz mentioned, keep in mind that our basic and default 2 configs are sparse, and they don't always define all the values available for hooks. So it's important to know how to locate these settings. All of our shipped apps are available in GitHub, so you can check them there if you're curious about what's available in terms of hooks. You can divide a hook simply by specifying a path in an app setting within your configuration. So this is just a string that tells the app where to find the code to execute for a given hook. And you can see a couple of examples of where hook code can be defined. For example, in the engine code or in the configuration itself, which is what you specify when you override a hook definition, typically. There are other special tokens as well that you can read about in the documentation. Hooks allow you to do more than just override the behavior. You can subclass existing hooks to modify only the parts you need. So for example, this specification says, take the behavior defined in the first path here before the colon and override some of that behavior with the code defined in the file specified after the colon. So that colon syntax is an inheritance behavior that's possible through the hook system. So now let's work through a couple of simple production examples to see how to customize hook behavior. And we'll start with a request from production that says the art department would like to add a watermark layer with every published image they load. So how do we do this? We know that Shotgun ships with the ability to load images into Photoshop. That's part of our default integration. So maybe we can piggyback on that and just add a little bit of code to add this new watermark layer. So in this video, you'll see the default loader behavior. We browse assets for the current project. We find the asset we're interested in. We see the published image that we're interested in loading. And when we load it, we see there's a new image in Photoshop with a single background layer. And that's pretty much it. Let's see if we can take that default behavior and customize it with the watermark that's been requested. So the first thing we're going to need to do is find the existing hook source code that handles the Photoshop imports. As we saw before, we can locate the info.yaml file via the Loader2 app on GitHub. The hook we need to modify is the actions hook. And by default, it's configured with the engine name token. This is one of the special tokens I mentioned before. This token will evaluate during the processing of the configuration, and the result is a hook that's called TK Photoshop cc_actions.py, which is found in the app itself. You can note the self token on the left of the specification. That's the indicator that the hook is expected to live within the app. And as mentioned before, you should double check your configuration to see if it is overriding this default value. So for this example, we'll assume that the starting point is the default to config, which doesn't override this hook value. If we look at this file, we can see two actions are defined. One is the open file, and the other one is called add as layer. So the request from production was to add an additional layer upon file open. So maybe we can modify the file open method to add the new layer, and then we might be able to reuse the existing add layer code to do exactly what we need. So the next question is, do we take over the hook or do we subclass it? Since we want to modify the existing behavior, subclassing makes a lot more sense. In general, if you can subclass the code, it's always a good idea. So this allows you to receive the updates to the default implementations that include new features and bug fixes. So for example, if the Toolkit team adds support for new file types or faster loading, for example, we want to make sure we get those changes through our customizations. So let's define our hook subclass. First, we'll create a file in our configuration that we define our custom behavior. So we'll save this file in the hooks folder and call it TK Multiloader2 add watermark. And then in the configuration, we'll update the Loader2 actions hook specifications to point to our new file. So note the subclass syntax down at the bottom that we saw earlier. And there's the file, and there's our extra specification. So what goes into this new file? This is all the code we need. We define our subclass, making sure to inherit from the correct base. Toolkit uses a special base class defined by the get hook base class method in SGTK. So this will return the proper class given the configuration. In our case, this will return the default Photoshop action class that we saw earlier. Then we override the open file method, calling the base class implementation to actually import the file, and then we simply load the external watermark as a new layer, reusing the existing add layer code. And for reference, here's the watermark file that will be added as the watermark layer. So here's the same steps we ran before to load in the published file. So again, the exact same steps, but since we've modified the action and configured it, now we get the additional watermark layer when we open the file. So you can see the background layer and then the watermark as well. So let's do another example. For this one, production has asked that we ensure that for every publish, a task has been specified in the publisher to make sure that when we're publishing, we're associating these publishes in Shotgun with the right publish context. So let's see if we can block publishes that do not specify a task. That's our goal here. So again, we'll take a look at what happens by default without any changes before we make the customization. So you can drag and drop a file into the publisher and click validate. And even though we haven't specified a task on the right, the validation is successful. You can see the green check marks there. So like before, we need to find the existing hook source code that handles publishing files. So looking into the info.yaml file via the publish to app on GitHub, we see that this app's configuration is a little bit different. Parsing this setting definition is beyond the scope of this talk, but it is different than the simple loader hook we saw before. This is basically a list of hooks that's defined by the publisher. So if you need further information about that, I can point you to the publish to docs, or you can just ask me. But just know that the publish file hook is the hook we're interested in modifying. Each publish plugin has a validate method that says whether the publish is ready to execute. So this is inside of that publish file hook. And since we're simply adding on to this existing behavior, we'll see if we can subclass this hook and add the new logic to ensure that a task is set for the item. Once again, we define our hook subclass. We create a file in our configuration that will define the custom behavior. In this case, we call it ensure task.py. And in our configuration, we'll update the publish to default plugin to include our new hook as a subclass. And that's that syntax there at the bottom. As with the loader example, we need to define our subclass, making sure to inherit from the correct base. We're going to override the validate method. And again, this is all the code needed to make these changes. And all we're going to do is check to see if the item's context is defined. And if not, log an error. And if so, we'll just continue with the base class logic. So we don't have to actually implement that again. So here's the same video, same steps, this time with our new hook in place that we've configured. And again, we're going to drag the file in and we're going to validate it. And you can see still no task, but this time we get the warning that and the error that there is no task set. So if we set a task on it and run the validation again, this time it should succeed. And that way we know that our plugin and our custom behavior is working. So even though these examples were fairly minimal, hopefully you can start to get an idea of how powerful the hooks are and how you can really get the existing Toolkit apps to behave in a way that works for your studio. So to finish up this session, I just want to give a few additional pointers around hooks that are hopefully helpful for you if you start doing customizations. Overriding versus subclassing. When it comes time to alter the behavior of a hook, it's important to know what makes sense for you in terms of how you write your hooks. So we'll take just a simple example called the default hook. It doesn't matter what app this is. The blue boxes represent some type of implementation. And if we completely override that hook with our own implementation, covering over all the source code and replacing the reference in the configuration, we still get the same behavior we want. But if updates are made to the app itself, then the overridden hook will not receive that new implementation. Maybe that's perfectly fine if you've completely changed the behavior of your app, or you don't want you want to make sure you don't want those updates. That's fine, but just something to be aware of if you completely override the hook with your own implementation. And on the flip side, if you subclass your hook and inherit the existing behavior, maintaining the original with your changes, your modified implementation, and then inheriting that outline box represents inheriting the implementation from the default. Then when the update comes and you get new implementation, then you will inherit those changes as well. So really simple visualizations, but for folks who are new to Toolkit or aren't programmers by trade, hopefully this gives you an understanding of the difference here. Namespacing is important when it comes to hooks. Toolkit doesn't really care what you call your hooks so long as you reference them properly in the configuration. So in the examples we looked at, we just dropped the hooks into a folder with the name of the app. But what if we want to add similar watermark behavior to the loader and nuke? Sometimes it can be useful to include more directory structure in your hook folder to make it clear what the scope of the hook's behavior is. So the structure is up to you, but because Toolkit apps are often used in multiple DCCs, it is important to keep your hooks organized in a way that keeps things clear in your configuration. So you can see on the left, we're not using any sort of namespacing for the engine that the behavior works within, and then on the right we have different behavior, whether it's Photoshop or Nuke. Source control, hopefully this is obvious, but it's a good idea to keep your hooks under source control. So if you have your configuration under source control, including your hooks in there, if you find yourself reusing the same ones across projects, it's a good idea. There are other ways to keep your hooks under source control outside of your configuration. You can look at the developer docs for more info there. I also want to point out a couple of properties available to you when writing or modifying a hook. Each hook class derives from a common base that defines these properties, so you always have access to them when writing hooks. There's the SGTK property, which gives you a reference to the core API. The parent property will give you the parent of the current Toolkit bundle. So if you're writing an app, the hook's parent would be the app, the publisher, or the loader, for example. The disk location property will give you the folder on disk where the hook lives. So this is useful if you have associated files that travel with your hook. So in the publisher, for example, icons that go with your published items or published tasks is good to have around. And then there's the logger property, which gives you access to the logger instance you can use for debugging while working on your custom hooks. Another good thing to know about is the load framework method available to the hook. This allows you to load and import code that is managed externally and typically reusable across apps within your hook. This requires that the framework is defined in your app's manifest and required by the app in order to be available in the environment that the app is running. If you want to, you can see the framework as it's configured in the environment here. Note the long name with the version string appended. This is the string you want to pass to the load framework method. So this is what will be called once the engine is running, and how the method does the lookup. Once the framework is loaded, you can import any module defined by the framework and begin using it. So this example is using Qt widgets framework, but this could easily be your own custom framework that manages code reused by your studio's custom apps. And then finally, I wanted to point out core hooks. There are hooks that can alter the behavior of Toolkit itself, not just an individual app. These are defined per project and live in a separate hooks folder in your configuration. You can find out more about these hooks in the TK core repo itself on GitHub or in the Toolkit documentation. And then these are just links to all the things that are relevant to hooks. These are included in the Dev Day repo, so you can just go to that Dev Day repo and find links to all these things there if you want to do more reading. And that's all I have for managing hooks. If you guys have any questions, I'll be happy to answer them. Or if you have questions about any of the other sessions from this webinar, we'll be happy to answer those as well.
Doesn't look like there are any questions. So I guess we can finish up. Thanks, guys, for taking the time. I know it was a long one today. Next week, oh, there is a question. Actually, can you suggest best practices to share Python modules imported in multiple hooks for different apps or frameworks the best way to do that?
Yeah, as long as your app requires the frameworks, if you could do it through frameworks. I don't know if they're custom apps or if you're talking about like some of the shipped apps, like the publisher loader stuff, but multiple hooks for different apps. Yeah, I guess, yeah, I have to think about it. I have to play around with it. I don't know if anybody else has any ideas, but frameworks would be one way if they're custom apps.
Or just like Studio Python modules that are somewhere that you bring into your, outside of your pipeline configuration. If it's something that's not project specific that you want to use across configs, that's what I would suggest.
Yeah. I don't know if you meant like sharing code within the toolkit sense, like, or if, of course, like Tannaz says, outside of Toolkit, if you're just managing your Python through the system, then yeah, that's totally doable.
Yeah, it's all Python, so you can always pull things in non-toolkit specific ways, if that makes sense. Cool. All right, it doesn't seem like there's any more questions, so I think we can close it. We're going to do the last one of these next Thursday. Let me change my settings so that Josh doesn't have to be on camera when I'm talking. There we go. The last one of these next Thursday at the same time, which is 10 a.m. Pacific time. We're going to go into advanced topics on that one. So we'll look into writing a custom toolkit app, cloud configuration for multi-location workflows, and also some source control questions for your configuration. And finally, integrating Toolkit and Shotgun with Forge, which is Autodesk's APIs for accessing their cloud services. So a quick demo to show sort of a tease of some cool stuff that you can do there. And as soon as the recording for this one is up on YouTube, I'll share that link on the Shotgun dev list. You have the link to resources in the GitHub repo. I think we're good here. I hope you guys enjoy the rest of your day or evening, depending on where in the world you are. Thanks very much for spending the time with us. See you at the next one. Bye all.